Hello, everybody. Welcome to section 1.9. We're going to be talking about graphing basics today. So let's start off by looking at a coordinate plane first. So we have coordinate plane. And so coordinate plane, you probably have seen this before. We have two axes. We have a y-axis and an x-axis, and they are usually ticked in irregular intervals, like so. And actually, a coordinate plane is divided up into 4 quadrants. So this is the first one, this is the second, the third, and the fourth quadrant. And so when we're going to use a coordinate plane, we're usually going to be graphing either points and or functions. So if we're graphing a point in the first coordinate, so we go, for example, we want to do 3, 2. We go 1, 2, 3 on the x-axis and 2 up. So that would be 3, 2. For another point, if we wanted to graph, say, -1, 5, we're going to go 1 in the negative direction on the x-axis and up 5 in the y direction. So we get -1, 5. If we wanted to graph something like that had 2 negative numbers, like -3, -3, we would go 3 in the negative direction on the x-axis and 3 down in the negative direction of the y-axis. 1, 2, 3. And that would be here. And then if we wanted to do something like 5, -1, we'd go 5 in the positive x direction, 4, 5, and then down 1 in the negative y direction. So that'd be 5, -1. So the coordinates, what they do is that everything in the first coordinate is going to be positive for both. Everything in the second one is going to be -x, +y. The third coordinate, both are negative, and the fourth coordinate, or fourth quadrant, sorry, the x value is positive and the y value is negative, right? So once we kind of understand the coordinate plane, we can start looking at 2 main ideas with points and their relations between each other. So we can look at first the distance formula. And this is for finding the distance between 2 points on the plane. So the distance between some point A, where it's x1, y1, and B, where it is x2, y2, is given by the formula square root x2 minus x1 squared plus y2 minus y1 squared. And this looks really contrived, and if you're curious about where this comes from, it's really the Pythagorean theorem, but don't worry too much about that. You don't need to know how to find the distance formula. And I'll show you an example of how to use it here in just a minute. But the other important formula that you're going to want to know is the midpoint formula. And so this is for finding the middle point between 2 points A, just like x1, y1, and B, x2, y2, just like the previous example. That formula is a pair because the midpoint is a point on the coordinate plane, and it is given by this formula right here. So x1 plus x2 divided by 2, and the y coordinate is y1 plus y2 divided by 2. Cool. So let's see these 2 things in action. Let's do an example. Let's find the distance and midpoint between, let's do -3, 2, and how about -6 and -2? There's some negative numbers in there, so you know how to use those. All right, so let's do distance first. So we know from above that our equation is going to be x2 minus x1 squared plus y2 minus y1 squared. And if we plug in, so this is our x1, y1, and this is our x2 and our y2 here. So if we plug these in, we have x2 is -6 minus, and then x1 is -3. So this is -3 squared plus, and then y2 is -2 minus y1 is 2 squared. And then if we do some simplifying, we get -6 minus -3 is -6 plus 3. So we get -3 squared. And then over here, this becomes -4 squared. And then -3 times -3 is just 9. And then -4 times -4 is 16. And then if we combine these, we get square root of 25, and that is 5. So their distance is 5 units. Cool. For their midpoint, we're going to use the formula. So remember, it's x1 plus x2 over 2, then y1 plus y2 over 2. And so if we plug those things in, if we remember, x1 is -3, x2 is -6. So we get -3 minus 6 over 2 in the x slot. And then y1 is 2, y2 is -2. So we get 2 plus -2 over 2. Cool. And then if we simplify a little bit, we get -9 halves over these two cancel out. We get 0 halves. And then, so we get 9 halves, 0. So this is the midpoint. Cool. So that is how we use the distance and midpoint formulas. And so let's talk about using our point plotting ideas and abilities to sketch graphs of functions. So sketching graphs. All right, so let's say, for example, we have a formula. So let's say we want to sketch a graph of, let's say, y equals x squared plus 2. So what we're going to do is we're going to pick some points and we're going to plot them. And then we're just going to connect them together with some lines. So to do that, I'm going to pick some x values. So let's just do these 5, -2, -1, 0, 1, and 2. And to find what the y value is going to be for those, we're going to take x, we're going to plug it into our formula here, and we'll see what spits out for y. So for -2, if we plug that in, we get -2 squared plus 2. And so -2 times -2 is 4. 4 plus 2 is 6. And then for this one, it's -1 squared plus 2, which if you do the math is going to be 3. And then this one is 0 squared plus 2, which is just 2. And then 1 squared plus 2 is 3 again, and then +2 squared plus 2 is 6 again. So now we can use this information to sketch a rough graph. Actually, I'm gonna do this further down so I have more room. Sketch a rough graph like so. So this is x, this is y. And so our first point is -2, 6. So we want to go back 2 on the x-axis and then 6 up. So 1, 2, 3, 4, 5, and then 6 would be up here. So that's our first point, -2, 6. And then our next point is -1, 3. So that's back 1 on the x-axis and up 3 right here. And then we have 0, 2. So 0 on the x-axis, up 2 on the y. 0, 2. And then we also have 1, 3, which would be here. And then we have 2, 6. And then we just connect these lines together. So that would look like this. A parabola. That's kind of what we expected to see because we do have this x squared term here. So that's good. Everything kind of checks out. That's how you sketch graphs by just plotting points. We will get faster at plotting graphs by sort of looking at transformations of functions in chapter 2. But for now, like the basic kind of graphs that you're going to want to know so that you kind of can expect what basic shape to draw when you sketch a graph are these. So basic graphs look like this. So the first one obviously is a line, and we'll talk more about those in the next section. So this is the basic equation, and then a graph of a basic line just looks like this. It's a line. No big surprise there, right? This would be y equals x. The second one that you're going to want to know is absolute value. And absolute value, the equation will look something like this here. Again, we'll go over these sort of things in more depth later on. And absolute value equations usually look like a V shape. So this would just be y equals absolute value of x. The V does not have to be pointing up. It can also be pointing down. So bear that in mind when you're dealing with absolute values. And the last like basic one is a parabola, right? So this is just a quadratic, which we have seen before, sort of in this form. And then these are always kind of like their classic U shape, looking kind of like this. Right. And again, this U can be pointing down as well. So this would be just y equals x squared. Cool. Oh, and sorry, there is one more. Circle. A circle is described as a little bit differently from the others because it's described implicitly, is what we say. So this is where the center of the circle is the point HK, and the radius is R. So the R here, this is R squared. Sorry if that's maybe a little unclear. R squared. That's the radius. And then H and K describe where the center of the circle is. So I've usually, a circle would look, as a circle should look just like this, right? This would be x plus, or x squared plus y squared equals 1. And then if we wanted to look at like an example of how to graph a circle, if we graphed x plus 1 squared plus y squared equals, and I'm gonna write it as 4 squared. Secretly, there is a y plus 0 squared here. So we know that the center is going to be, and you have to be careful, there are minus signs here in the formula. So when we go to look at the center is actually going to be -1 from this here and 0. And the radius is going to be 4. And so if we were to graph this circle, we would put its center at -1, 0, which would be -1. So one step in the negative x direction and then nowhere to go for the y direction. So it's just going to be right there. Make this a color. Just going to be right there like that. And then the radius is going to be 4. So we're going to go 1, 2, 3, 4 points out. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 4 points out from the center, and then we're just going to connect them. Forgive my poor artistic ability here. But that's how we graph that circle. Cool. The last thing in this section to really take note of is intercepts. So an intercept is where the graph crosses one of the axes. So an x-intercept is where the graph crosses the x-axis, and a y-intercept is the same thing but with the y-axis. So it's where the graph crosses the y-axis. So looking at pictures, there's 4 intercepts for this graph of the circle. And if we looked at, say, like this parabola, or no, this line, its x and y intercept are the same with the origin right here. So intercepts are important because sometimes they are actually like solutions to equations, especially when we're looking at quadratics. So we need to kind of know how to find them. So let's look at an example. Find all x and y intercepts for the equation. Let's do y equals x squared minus 4. So let's try to do this without graphing it, so we can like find it precisely. So let's look at some of the steps for that. 1, if possible, factor. So in this case, if you look at this, this is a difference of squares. So we have y equals x minus 2, x plus 2. Now, factoring isn't necessary, but it makes the process a lot easier, especially for polynomials. Second, for finding the x-intercept, set y equals 0. So in our case, that means we have 0 equals x minus 2, x plus 2. And then we solve for x. So the x-intercepts are at x equals 2 and x equals -2. And x-intercepts are always when y equals 0, right? It's where we're at the x-axis. So the points would be 2, 0, and -2, 0. Cool. And then for the y-intercept, set x equal to 0, right? Because y-intercepts happen where we're on the y-axis, so where x equals 0. So in our case, that would be y equals, and then if we plug in 0 to this equation right here, we have 0 minus 2, 0 plus 2. And then we get negative 2 times positive 2, which is going to be negative 4. And so our y-intercept is going to be x is 0 from here, negative 4. So these 3 points are our intercepts, which is good because now actually, if you graphed this, you would see that the parabola looks like this, and that this here is this point, and then the x points, the x-intercepts are right here, right? So this, if you did graph this, you would find that it does cross the y-axis at 0, negative 4, and it does cross the x-axis at 2, 0, and negative 2, 0. Cool. Okay, that's it for this section. Keep working on the homework, and I hope to see you in office hours.